Welcome back to another LeetCode easy problem. This time we are dealing with 1539, Kth Missing Positive Number. The problem is that we're giving an array of positive integers sorted in strictly increasing order and an integer k. And we're supposed to return the kth positive integer that is missing from this array. And there's some bounds on the length of the array, on the values that we have in the array. Mouse value is 1. And let me see, is there, or can k be larger than the length of the array? We don't really know. So k can actually be larger. So I wonder what we should return in case k is larger than the length of the array. Maybe we should return -1. The problem doesn't really tell us. But since it's an easy one, it's probably safe to assume that k will never be larger than the length of the array. So yeah, example, let's look at this one. So we have an array, it starts at 2, but the values start at 1. So 1 is a missing number, 2 is not 1. So 1 was the first missing number. We have 2, 3, 4, then 5 and 6 are missing. So we have 7 in the array, then 8 and 9 are missing. So 1, 2, 3, 4, 5. So 9 should be our answer because that's the fifth number that's missing. In this example, we're looking for the second missing number, and we have 1, 2, 3, 4, and 6 is missing. Oh, I see now. So it doesn't really matter that k is larger than the length of the array, because we're really only interested in what is the kth missing number. Okay, so in this case, it's 6. So it's the end. Okay. Interesting, right. So I've solved this before, apparently, but some years ago. So yeah, let's try to solve this again. So I think it's quite obvious that we could just do exactly what I did here by hand. We could just iterate through the array and then count the spaces between the numbers to keep track of how many numbers are actually missing. And as soon as we as soon as we run over k, we know that we found which number is missing. So yeah, so let's do that. So I'm proposing an O of n time and O of 1 space solution, where we just iterate over the elements in the array for in array. Well, actually, I'm going to say n is equal to, well, n is going to be 0, and I'm just going to use an iterate, just going to iterate over it like so. In range length. Oh, well, how could I do this? Well, I want the n to be available to us after we exit the loop. Maybe we start at index 0. While I is smaller than length array. Actually, I'm not quite sure. Maybe after a for loop, we still have access to the value. Should we do a quick test for n in range 10? We're not going to do anything, and then we're going to print n. Let's see what happens. Okay. We're printing n, standard out 9. So we iterated up to 10. So n actually has the last value. Interesting. So that works. So nice. So we can just iterate over all of the elements in the array like so. For n in array. By the way, those tests, you probably don't want to do them during an interview. But here for practice, it's fine to do this. For n in array. And we're going to keep track of the previous value. Prev value of n is 0. And now we can calculate how many numbers we've skipped. And that's simply n minus the previous. And skip. And the previous plus 1. Because if the values are 1, 2, 3, we want skip to be 0 each time, right? So skip should tell us exactly how many we're skipping. And now if skip is larger than k, then we know that, we can't fully skip all of the numbers. but we have to compute exactly what was the kth number. So we have to do this in a second here. Otherwise, we can say k minus equal skip. Right? And yeah, and then finally here at the end, if k, well, if we go here, then that means n is the last value in array, and k is still some value greater than 0. So all we need to do is add k to n to get the result, I think. Return n plus k. So if, yes, I think so. So if we have this example here, so none of the numbers are missing. So we never, so skip is always 0. We never decreasing our k. And then the last value will be 4. And now if we add 2, we get 6. So that looks right. So in that case, the kth missing number is exactly that value. Now in the other cases, if the skip is larger than k, we could apply the same logic, right? We could return not something where we use skip, or we could also do a return the previous n plus whatever k is. And yeah, let's test this with a quick example. Where do we have? So 9 was one example. Let's go through this one step by step. So in the beginning, maybe I should write this down. We have pref n, and we have n, and we have maybe skip, and we have k. So we start with pref 0. Our n would be 2. Our skip would be 1. So we're going to decrease k from 5 to 4. Next, now our previous is n. We have 3 as n, so our skip is 0, and we're not going to change k. Next iteration, we have 4. So that's the same scenario. 4, we're not, our n is, sorry, a predecessor 3, our n is 4, our skip is 0, we're not going to change k. Then in the next step, we're going to 7. So our predecessor is 4, our n is 7, and now our skip is 2, right? Skip is n, so 7 minus 5, so that's 2. We're going to update our k to 2 by subtracting these two. Next step, we run into the 11, right? So the predecessor is 7, the n is 11, and now skip has the value of 3, and 3 is larger than 2, right? So what we do now is we compute previous, the result is the pref plus k, which equals 7 plus 2, which is exactly 9. So that works out as well. So I'm confident now that this will work. Let's just run the test cases. And we're getting an error. Why? K output 2. Okay. Skip. Maybe we have to have an equal here. If skip is the same or equal, yeah, that's one thing. Oh, I was so convinced that my logic works, but it doesn't. So let's go back to the example. So I think this one was okay, but maybe my code doesn't exactly do what I wanted to do. So let's just print this. Oh, I know what the error is. We don't keep track of the predecessor, do we? That is the problem here. That is the problem here. Yeah, that was the problem. Cool. So both test cases now pass. I'm confident that this should now work on all test cases, but let's see. And it doesn't work. So here we go. We have an array that has only one element, and our k is only 1, but our output is 2. Interesting. So that is an edge case definitely that we don't have to take, that we haven't taken into account. So we want to find the first missing number. So we start with 0. Just gonna do this. It's 0. Our n is 2. Our skip is 1. And our original k is also 1. So now it's larger or equal to. So yeah, so this is where we need the larger or equal. Yeah, so maybe that was right when I put it there earlier. Our test case still pass. So let's submit it with that. All right, so that was it. So again, yeah, 2 small but significant errors. But with practice and attention to detail, those hopefully get less and less and less. Have a look if there are any other faster solutions of n time or of 1 space. Okay. So this one iterates over all of the elements, but this is a different O of n. So what is it? If I is smaller than k, then it adds k. Interesting. So this is nice. This is interesting. This simplifies the logic a little bit. So we iterate over all of the numbers in the array for n in array. And if n smaller or equal than k, we're going to increase k by 1. Aha, so it's basically using, well, if we run into a number that is smaller than k, oh, I see. So it runs through the array. And as long as we're not skipping any elements, we're just increasing k. And as soon as we run to the case where actually the value n is larger or equal than k, we just return k. That's very smart. That is very smart. And the edge case that we just had in our code, that is handled by, I suppose, by this. Oh no, yeah, no. Yeah, that's basically handled by the edge case where the first element in the array is larger than our k. That's handled by this as well. Yeah, that's even nicer. That is even nicer because it's just shorter. So that's a great idea. I like that idea. And I suppose that will also work when we submit it. Nice. Cool. Well, I hope you had fun with that one. Thanks for watching.